Hey everyone, today we are going to continue looking at matrices and we're going to look at how to multiply with a matrix today. We're going to look at a couple different types of multiplication. That might sound funny to you, but trust me, it's a thing. And solve some more equations. So get your notes out, get ready, and here we go. So the first kind of multiplication that we're going to look at is called scalar multiplication. And scalar multiplication multiplies every element in a matrix by a scalar or coefficient. So essentially it's if you have something like 3 times all these numbers, and we're going to think of it as distributive property. Essentially what we're doing is taking that scalar multiple, or that scalar, the number 3, and multiplying it by each of the elements inside. So 3 times x, 3 times a, 3 times y, 3 times b, 3 times z, 3 times c. It's just a fancy way of saying the distributive property. So if I apply that to this one here, when I look at 2a, that should say 2b, my bad. So if I have 2b, or not 2b, just kidding. 2b, it's going to look like 2 times this matrix. And then I've got plus 4 times d. So that would be 3, -1, -2, -3, 2, and 4. So I'm going to distribute these, and I would get 0, 4, -4, 2, -2, and 0. I just took each element in this matrix and multiplied it by 2. For the second one, I'm going to multiply each element in this matrix by 4. Oops. So I'm going to get 12, -12, -4, 8, -8, and 16. And my final step to simplify this is to add these together. So remember, with adding them together, I'm looking at the corresponding elements. So 0 plus 12 would give me 12. 4 plus -12 would give me -8. -4 plus -4 is -8, and 2 plus 8 is 10. -2 plus -8 is -10. 0 plus 16 is 16. So there you go. That's how we would take care of this kind of problem with scalar multiplication. So now we're going to look at how to solve an equation. So I'm trying to get this x by itself. And so what I have to do is say, okay, what do I need to do to simplify this? The first thing I'm going to do is scalar multiplication. I'm going to multiply this first matrix by 2. So this is going to give me 0, 2, 6, and -8 minus 3x equals 9, -6, 1, -2. And so that's what we would get. I need to move this to the other side. So even though this is a minus sign, this right here is a positive matrix, so I'm going to subtract it to both sides. So I'm going to subtract it over to here. And that's going to cancel out on this side. I'm going to get -3x equals, and now I'm going to use kind of my little trick, if you will, where I change this minus to a plus, and I change the sign of everything in the matrix that comes after it. So I'm going to get -2, -6, and +8. Adding all those together would give me 0, -8, -5, and +6. There we go. So now, if I wanted, the final step to solve for x is we think of it as dividing by 3, but really we don't do any division with matrices. So instead what we want to do is multiply by the reciprocal, because dividing by 3 is really the same as multiplying by -1/3. That would cancel. So I'm going to multiply by -1/3 on both sides, and I'm going to get fractions. Everyone's favorite. X equals 0, positive 8/3, positive 5/3, and negative 2. And that would be my final answer. All right, so let's make things complicateder. If we just have two matrices that we are multiplying together, it's going to take a bit of effort, and you're going to have to really think carefully about this. So to get my answer, what I need to do is I'm going to take the first row. With the first matrix, I'm always looking at rows. The second matrix, I'm always looking at columns. So for the first matrix, I care about rows, second matrix, columns. And I'm going to look at the first row of the first matrix and the first column of the second matrix. And I'm going to do 4 times 6 plus 3 times 9. Now, that seems really weird, but look at where I got each of these numbers. This 4 came from this 4 right here, and I got the 6 from right here. So essentially, I'm starting with the row, I'm starting from the left and working my way to the right. That's how I got 4 and then 3. I got 6 and 9 because I worked my way from the top to the bottom. So I've got 6 here, 9 here. When I simplify these, I get 24 plus 27, which is 51, if I'm not mistaken. And this is going to go in the first spot. Think of it this way. I had the first row, first column. If I were to overlap those into one column, I was looking at the first row, first column. So I'm looking at this point right here, or this first element. All right. I'm going to repeat this again. Nope, I don't want to use that color. I already used it. All right. Next, I'm going to look at the first row in the second column. And so I'm going to do 4 from this 4 right here, and then this 3, 4 times 3, plus this 3, and the second 4. So I'm always multiplying together a number from the row of the first and a number from the column of the second. And in this case, I would get 12 plus 12, which would give me 24. And again, think about it this way. I'm finding first row, second column, so I want this point right here. So 24 is going to go here. We've got 9, 7, and then the first row. So I'm going to have 9 times 6 plus 7 times 9. This is going to give me 54 plus 63, which is going to give me 109. All right, last one. We'll do red. I'm going to have the second row, second column, and I'm going to get 9 times 3 plus 7 times 4. 27 plus 28, which would give me 55. I know that this does not seem natural. It's weird and it takes some getting used to, but once you find the pattern, it's really not that bad. Just make sure that when you're multiplying numbers together, you're taking one from the first and one from the second. It should never be 9 times 7 plus 3 times 4. That is not what we're doing. I don't know what kind of tricks you can find. Remember, it really just takes practice, at least in my experience. So let's look at another one. I'm going to go through this one a little bit quicker, but I'm going to be looking at first row, first column. I'd get 0 times negative 2 plus 1 times negative 1 plus 0 times 0. Do you see where I got all those things? This one's not going to be too bad. It's actually just negative 1. And it was the first row, first column, so I'm going to have a 1. Or sorry, negative 1. Next, I have 0 times 2 I'm looking at the second column now with the first row, plus 1 times 1 plus 0 times negative 1. And that's going to give me positive 1. First row, second column, so that's where it goes. Next one, I'm looking at the third column with the first row now, so I get 0 times 2 plus 1 times 1 plus 0 times negative 1. And that gives me 1. All right, so fill in the bottom row, left to right, see what you get, and then come back and check your work. All right, so this is what you should have gotten when you plug all these in. You can see the work that's shown here, so take a second, check your work, make sure it matches, and we're going to go ahead and move on. So, some rules that you should be aware of are the dimensions of the product of a matrix. So if matrix A is an m by n matrix, and matrix B is an n by p matrix, then the product matrix AB is an m by p matrix. What this means is, if you look at this, we're saying we take mn, this is A, and we're multiplying it by B. What it's saying is that the end result will be an m by p. So essentially, we have to look at the middle terms and make sure that they match. If those middle terms do not match, they're not the same number, then we cannot multiply them. And then my final dimensions will be the ones on the outside. So with this one, I had a 2 by 3 and a 3 by 3. These inside numbers match, and my final result should have been a 2 by 3, which it was. I had 2 rows, 3 columns. So if I look at these, I could do, it's very important to pay attention to order in this, I could do a 3 by 2 and a 2 by 4. What would my final dimensions be of the answer? Since it works with the 2's in the middle being the same, I would get a 3 by 4. But if I switch the order, let's say I flip-flopped which one went first. So I took this one first instead. I would have a 2 by 4 and a 3 by 2. These numbers now do not match. And when those inner numbers don't match, we say that this is undefined. If you try to multiply them together, it won't work because you'll either have too many rows or not enough rows for all of the columns in the second matrix. All right, so for this one, we're just determining if the product exists or doesn't exist. Is it defined or undefined? We don't actually have to find it. So with RS, we have to look at what is the dimensions. Oops. There we go. All right, so the dimensions of this one would be a 2 by 2. The dimensions of this one would be a 2 by 4. So if I put these in the order of R times S, oops, and then SR, it's only going to work for one of these. Which one is it going to work for? It's going to work for the first one, because in the first one, that's where our middle numbers are the same. So this one would be defined, and this one would be undefined. All right, so that's multiplying matrices. Again, if you're having trouble with this, it's perfectly natural. This is something very different from anything that we've really looked at. So give yourself some grace and be patient with yourself. Practice the problems that I'm going to give you and just try it out. Be patient. It'll be fine. As always, please let me know if you have any questions. I would be happy to help.